All right, hello and welcome. Today, we're jumping right into AWS messaging. This is the stuff that works behind the scenes, the invisible engine that really powers modern scalable apps.
So, have you ever stopped to wonder how a website can handle thousands of orders during a huge sale, or how a social media app just handles millions of photo uploads at the same time without grinding to a halt? It all just seems to work, right?
Well, the secret isn't magic. It's actually a really powerful architectural pattern called asynchronous messaging. We're going to see how it all works by looking at three core AWS services. SQS for simple scalable queues, SQS FIFO for when the order of things is absolutely critical, and then SNS for broadcasting messages to, well, everyone. So let's get into it. We're going to start with the original workhorse, the foundational tool for decoupling your applications, Amazon SQS, which stands for Simple Queues Service. Think of SQS as a digital waiting line, or maybe like a shared to-do list that sits between different parts of your application. So instead of one piece of your app directly telling another what to do and then just waiting, it just drops a task, a message, into this queue. This simple act of decoupling is what gives applications such incredible resilience and scale. Now, the standard version of SQS is built for massive, massive scale. It gives you practically unlimited throughput, and it guarantees at least once delivery, so you can be confident your message will get there. But, and this is a big but, here's the key trade-off. It uses best effort ordering. What that means is messages might not get processed in the exact sequence they were sent. For a ton of background jobs, that's totally fine. It's a trade you're willing to make for incredible speed and scale. And here we see that pattern in action. So a user uploads a video. Instead of your web server getting totally stuck processing that huge file, it just fires off a, hey, process this video message into an SQS queue. And that's it. The user gets a super snappy response right away. Meanwhile, a completely separate worker service can just pick up that job from the queue whenever it has the capacity. The two systems are completely decoupled. They don't even need to know the other exists, only that this shared queue is there. That's the real magic of it. So this brings us to a really important question. I mean, what if you're processing something like financial transactions or updating a customer's order history? In those cases, yeah, processing things out of sequence would be a total disaster. For exactly that situation, AWS gives us a specialized tool. SQS FIFO. And FIFO, as you might guess, stands for first in, first out. Okay, here are the two game-changing differences. With standard SQS, you get best effort ordering. With FIFO, you get a guarantee of strict first in, first out order. Then, with standard, you get at least once delivery, which, can sometimes lead to duplicate messages. FIFO, on the other hand, gives you exactly once processing. No duplicates, period. This level of precision makes FIFO queues absolutely essential for any operation where the sequence and the uniqueness of an action are non-negotiable. We're talking about processing customer orders, managing inventory levels, updating a bank ledger, things where the order of events and making sure there are no duplicates are just paramount. Now, of course, these guarantees, they come with a trade-off. You get lower throughput compared to standard queues. That's just the price you pay for that precision. But FIFO has a really clever trick up its sleeve for scaling called message groups. This feature lets you have multiple independent ordered streams all inside a single queue, so you can still process things in parallel while preserving that strict order within each of those groups. Pretty smart. So the really crucial point here is that FIFO enables something called idempotency. It's a bit of a technical term, but it has a really simple meaning. Doing something multiple times has the exact same effect as doing it just once. With FIFO's exactly once processing, if you accidentally send a charge this customer message twice, the system is smart enough to process it only one time. That's a critical safety net. Okay, so far we've only really talked about one-to-one communication, right? A single producer drops a message for a single consumer. But what if you need to announce an event to many different systems all at the same time? Well, that's not a queue, that's a broadcast. And for that, we use Amazon SNS, or Simple Notification Service. It works on a completely different model called Publish-Subscribe, or PubSub. You publish one single message to a central topic, and SNS just broadcasts that message to all of its subscribers simultaneously. It's a push model, which is the opposite of SQS's pull model. SNS pushes the news out. With SQS, the workers have to come and pull the tasks. The real power here is the sheer variety of subscribers it can talk to. Just imagine a new user signs up on your site. You publish one single event to an SNS topic. And instantly, that one event can trigger a Lambda function, it can add a job to an analytics queue, call some external service, and send a welcome email and an SMS, all from a single trigger. This one-to-many fan-out pattern is really what makes event-driven architecture so incredibly powerful.
But what if you need both? I mean, what if you need to fan out a message, but you also have to make sure each recipient can process it reliably and at their own speed? Well, this brings us to the ultimate power combo, using SNS and SQS together.
This architecture, right here, is where it all comes together. A new order event is published once to an SNS topic. SNS then fans that message out to multiple subscribers. In this case, we have 2 SQS queues, one for billing, one for shipping. Each service gets its very own copy of the message to process at its own pace. And here is the key benefit. If the shipping service is down for maintenance, its queue just holds on to the messages. The billing service is completely unaffected and can just keep on processing orders. You get that broad distribution and incredible resilience. It's beautiful.
Okay, we have covered a lot of ground. So let's bring it all together and build a simple framework to help you choose the right tool for whatever job you're working on.
This table is basically your decision-making cheat sheet. So let's walk through it. Start with your use case. Is it a one-to-one job, a pull pattern? If so, you're looking at SQS. Now, the big question, does order matter? If the answer is no and you just need maximum throughput for async jobs, SQS Standard is your go-to workhorse. But if order must be guaranteed and you need exactly once delivery for things like transactions, then you have to use SQS FIFO. Now, what if your goal is to broadcast an event out to many subscribers, a push pattern? Then you just ignore the SQS columns entirely and go straight to SNS. It's all about matching the pattern on this chart to the problem you're trying to solve. So as we wrap this up, just think about the systems you're building right now. Where are the bottlenecks? Could you decouple a slow process with a standard SQS queue? Is there some critical workflow that just screams for the strict order and safety of FIFO? Or maybe you could use SNS to broadcast events and build a much more responsive, interconnected application. You have the patterns now. The only question is, which one is going to unlock your next project? Thanks for joining us.